Friends, good morning. I am Ramdas. I welcome you to my channel Maths from Basics for you. This is my class number 22. In the previous class, I have taught you variety of composite functions. I hope by now you are all comfortable with it and you would have understood it very well, and that is very evident from the feedback I have been getting from the YouTube. So what I advise you is, please follow the YouTube or my lessons regularly without any failure, because if you skip even one video or try to just brush it off, you won't learn mathematics. So mathematics has to be learned in depth if you have to seek admission in higher colleges or good professions or higher studies, or you have to do your engineering. Maths is must, don't neglect it. And some people have the habit of ignoring differentiation and integration. Please don't do that, because maths without differentiation and integration is incomplete, because you cannot be strong in mathematics if you avoid differentiation or integration. They are part and parcel of mathematics. Don't ignore it. So let's focus on it and try to understand maths at ease. So I am there to guide you. Remember funda, learn maths from basics. I am there to teach you math right from basics. So believe in me, I am going to handle the classes well. So dear students, we have studied differentiation in depth, that is sum rule, difference rule, product rule, quotient rule, composite functions, and today we are going to learn explicit and implicit functions. So what they are. So first we'll know what is an explicit function. Although we have done some problems on explicit functions, that time we are not aware of it, but today I am going to tell you what an explicit function is. So look at this, y equals f of x. I remember I have taught you this, where y equals a function of x, where y is a dependent variable, f is a function, and x is a independent variable. Imagine the function in which the dependent variable, I mean the dependent variable y is a function of independent variable x, is called an explicit function. So we have done some problems. We will do a few more problems only to make you aware. So on the contrary, and what is an implicit function? So let's know an implicit function. The dependent variable y cannot conveniently be expressed as a function of an independent variable x is called an implicit function. What it is? So let us take another equation. F of x comma y equals to 0. Here f of x comma y is an implicit functions, and today we are going to learn more on this, and we'll do some problems on this which is crucial for your examination point of view. Here you'll be learning how to solve equations and how to find d by dx. So here we'll know what it is. So we'll learn. There are some methods to find the derivative of an implicit function. What are they? We'll try to know. So dear students, before getting into implicit functions, I feel I'll refresh you with few examples so that you'll be able to recollect what an explicit function is. So let's take this problem. See, this problem is very peculiar. Y equals x to the power of x to the power of x, x to the power of x until infinity. How will you solve this problem? This problem is very, very simple. I remember when I was a student, I had got this problem, and as a student I did not know this problem. I left it and came. That was for 4 marks. I did not know, but throughout the day I was just wondering how did I get, because my lecturer did not teach us, and we did not have those times. We were childish. We did not think of going to library and learn all these things. We just ignored it. But in the examination we got this. It was really stunning. We're thinking how to solve this. So dear students, now you have got this problem before you. So it's an opportunity where you can learn such problems, because I know some lecturers will not teach you this in the schools or in the colleges, so I have got an opportunity to teach you. It's a very simple problem. Only you have to use a technique to solve this. The rest is very simple. So let's take this. We will work few problems, 1 or 2 problems on this. But the remaining problems are based on the same concept. Let's not waste more time on this. Let's start. No problem, dear students. Now we have been given y equals x to the power of x to the power of x. So can I write this? So can I write this y equals to y x to the power of y? Yes, because what is y? Y is x to the power of x, x to the power of x, x to the power of x till infinity. So you can write x equals to y equals to x to the power of y. Now let's take log on both sides. Taking log on both sides. Whenever you get something to the power, right thing, then take log. So this becomes log y equals to y log x. Now differentiate this. The once you differentiate, we can go to this. Let's differentiate this. What happens to this? By differentiating, that is d by dx of log y equals to d by dx of so here you have to use product rule because we have two functions. So what happens here? So this is d by dx of log y equals to, that is y into d by dx of log x plus log x into d by dx of y. So now we'll differentiate this. What happens here? So d by dx of log y is 1 by y. Differentiation of y is dy by dx equals to y keep as it is. D by dx of log x is 1 by x into 1 by x plus log x. D by dx of y is dy by dx into dy by dx. So I write this. So this can be written as what? 1 by y dy by dx, one step extra I am taking. So this becomes y by x plus log x into dy by dx. So now what I'll do, I have to keep dy by dx on one side and the non dy by dx on the other side. So what I'll do, I'll try to transfer this log x into dy by dx on the left hand side. So what happens is 1 by y dy by dx minus log x into dy by dx equals to y by, I'll write y by x as like this because this will come to the denominator. So I'll write like this, y by x. So what I'll do, I'll take common out of this. Dy by dx is common. Dy by dx common. So that becomes 1 by y we get here minus log x equals to y by x by, I'll write this 1 by y. I write this. Next what I'll do, I'll transfer this to the denominator. So what happens? So dy by dx equals to y by x divided by 1 by y minus log x. So we have to take LCM here. We'll take LCM. dy by dx equals to y by x. Y is here. I'll take 1 here. Y is LCM. Y goes 1 time. So this becomes 1. So 1 goes y time, y into this becomes y into log x. I'll rub this. Now dy by dx equals what? This y goes to denominator, numerator, and this x comes to the denominator. So what happens here? This become y goes on, that is y into y, and this x comes down. X into 1 minus y log x. So this y into y is y square, x into 1 minus y log x. So show that dy by dx equals to y square by x into 1 minus y log x. You have got it. Hence, therefore, dy by dx equals to y square by x into 1 minus y log x. Hence, proved. So we have done one problem on this, because what I had found as a difficult as a student, I am trying to make that problem for you, so that I have worked this problem for you, so that you will feel comfortable and elevated. That was my ambition, to teach you such problem. I have done this. So this comes under explicit function. Let us now do one more problem and then go to implicit function. So dear students, we have one more problem. Y equals sin x to the power of sin x to the power of sin x, and so on until infinity. So this problem looks complicated. It is not so. It's also similar to the problem we have done earlier. So it is very easy. So in the event you get this in examination, think of me and do this problem. So dear students, we will make this problem look very simple. Once I make it look simple, you will just have a smile on your lips and you will tell, oh sir, what is this? So let us do this. Can I write this as y equals sin x to the power of y, because y is sin x to the power, that is sin x to the power, sin x to the power, sin x to the power. So you can write this y equals sin x to the power y. So whenever you get such problems, infinity, write that y equals whatever they are given to the power y. So your problem is solved. You get a lot of problems like this. So it's very simple. Only thing you have to use this trick. The moment you use this trick, easy to solve this. Okay, dear student, we'll solve this problem. Let us see what happens here. Taking log on both sides. What happens? Log y equals to y log sin x. So what happens here? You have to use product rule. Here it's a composite function. Remember this, log is not log x into sin x, it is log of sin x. So it is a composite function. Remember this, don't go wrong. Be careful. So let's differentiate this. What happens here? By differentiating with respect to x, what happens? D by dx of log y equals to d by dx of y log of, I'll use a square bracket. Now use product rule for this. Let's start. What happens here? D by dx of log y equals to y d by dx of log of sin x plus log sin x into d by dx of y. I rub this. So now we differentiate. So this becomes what? Differentiation log y is 1 by y into differentiation of y is dy by dx equals to y into log of sin x becomes 1 by sin x and d by dx of sin x, that is into cos x plus log sin x d by dx of y is dy by dx. I'll rub this. So what I'll do, okay, wait, one more step. This is 1 by y into dy by dx equals to y into cos x by sin x is cot x. Cot x. Dear students, I remind you once again, try to remember the formulae, otherwise you cannot proceed, because if you don't know what is cos by sin x, there is no fun in doing this problem. So for the benefit of you students, I have put one latest video on YouTube where I have given a list of formulae. Try to practice, memorize that. That is class number 1, I think, whatever, 22, 21. So just 22, I think. Just go through that and try to learn this formula. It will be important to you, because in the middle of the problem, if you don't remember the formula, you cannot proceed. So try to memorize all formulas. So cos by sin is cot x plus log of sin x into dy by dx. So what I'll do, I'll try to group this dy by dx terms on one side and the remaining non dy by dx term from the other side. So that is what happens here. 1 by y dy by dx. I bring this here, this becomes log of sin x dy by dx equals to y cot x. I rub this. So what is common here? Dy by dx is common. I take dy by dx common, that is 1 by y minus log of sin x equals to y cot x. So we'll take LCM here itself, that is dy by dx equals into y, it goes one time 1 minus y goes one time, 1 into 1 is 1, here we have take 1 goes y times y into this, so this becomes y into y, I will use a small bracket, this is log of sin x. On the right hand side we have y into cot x. Cot x. So cross multiply dy by dx equals to, I'll take one more step. So 1 minus y log of sin x, I'll use a flower bracket, equals to y into y cot x. So this y has gone to the by cross multiplying. So this becomes, let me avoid one step, this becomes y into y becomes y square. I'll rub this, I'll write y square, and this becomes y square, because let me not write or repeat the same thing. So I'll rub this. So what we want? We want dy by dx. That is now dy by dx equals to what? I will write little y square into cot x divided by, this goes to denominator, that becomes 1 minus y into log of sin x. Therefore, dy by dx equals to y square into cot x 1 minus log of sin x. This is your answer. So dear student, let us include this. If y equals, because we have y, if y equals so and so, prove that dy by dx equals to y square into cot x divided by 1 minus y into log sin x. Hence proved. So dear students, this is more than enough, because I have done a lot of problems on explicit functions earlier. So these two importance, it came to my knowledge. I thought, let me do this problem even in the examination. If you get such problems, I don't want you to leave the problem as it is and come out of the examination, which I had done. So I want you to tackle this problem, attend to this problem and finish it. So whenever you see such problems, think of your lecturer, that is me. So you'll find always you'll remember me for such problems. Dear students, we have a lot of problems on this type, but for every problem the procedure is same. Let me not waste my time on this. So we'll put an end for explicit function. Now we'll see what an implicit functions are. So I'll write the definition for. Dear students, we have some rules or methods to find the derivative of an implicit functions. What are they? So while differentiating, differentiate each term of f of xy with respect to x, remembering, this is important, remembering to treat y as a function of x. This is the first point. Differentiate each term of f of xy with respect to x, remembering that remembering to treat y as a function of x, the first condition. And second condition is what? When you differentiate an equation, we will get dy by dx terms and non dy by dx terms. So here you are asked to bifurcate, that is to bring all the terms containing dy by dx on one side of the equation and the other terms not containing dy by dx on the other side. In the previous problem I have done y equals x to the power of x, x to the power of x, x to the power of x. I had explained to you and that problem. So what we did there, we separated dy by dx on the left hand side of the equation and brought all the non dy by dx terms on the right hand side. That's what he is asking you to do. So second point, bring the terms containing on one side of the equation and bring the terms containing dy by dx on one side of the equation and keep the non dy by on the other side. So supposing the equation, if you have y equals to x square, so dy by dx equals to 2x, right? So this is what is asking. Keep the dy by dx on one side and the remaining on the other side. We are not supposed to bring it like this: dy by dx minus 2x equals to 0. This cannot be an implicit function, because he has asked you the specific rule that you have to bring dy by dx term one side and the non dy by dx term on the other side. So in implicit function, this is not allowed. Okay, dear students. Now the third point, express dy by dx as a function of x or y or both. So dear students, these are the methods to find the derivative of implicit functions. First point, I repeat, differentiate each term of f of xy with respect to x, remembering that y is a function of x. Okay, so I have just, second one, bring the terms containing dy by dx on one side of the equation and keep the non dy by dx on the other side of the equation. If you want, you can write this: other side of the equation. Other side of the equation, that is, keep dy by dx on left hand side, other non dy by dx terms on the right hand side. That's what it means. Express dy by dx as a function of x or y or both. So these are the conditions to find, these are the methods, to find the derivative and implicit functions. So dear students, we have worked a lot of problems on explicit functions. Now we'll try to do some problems on implicit functions. The procedure, everything is same, but the method changes, because we have to adopt this method while doing problems on implicit function. We'll see how to go about it. We'll start with some problems, basic problems. I'll try to teach you from basics so that you will be able to understand this subject very well. So here I take small problems, that is basic problems, and later on gradually will increase the depth of implicit functions. So let's start with simple problems, few problems, and later on we'll get into some complicated problems. So sit tight to your table and relax and concentrate, focus on the board. Here I am. So dear students, we take a simple problem. Find dy by dx if x square plus y square equals to a square. So here, remember here, they will not give you y equals so and so, because it is implicit functions. Whatever you have given, you have to differentiate this, because you know that I have taught you f of xy equals to 0. First try to solve this, that is differentiate this with respect to x, both x as well as y, equate it to 0, and later on solve for dy by dx. So I'll show you how to go about it. So this is the first problem, and very simple problem started, so that you should feel comfortable, and beware, I am going to take some complicated and very important problems that will be asked in examinations. So dear students, this might be for 1 mark, but we'll go for complicated problems later. But I'll make the complicated problems very simple to you, so that the dullest student should be able to understand. I'll go slowly, steadily, and I see that everyone understands it. So before that, students, please like, share and subscribe to my channel. So let's start. Here, we are given x square plus y square plus a square. Let's differentiate this. So that is d by dx of x square plus d by dx of y square equals to d by dx of a square. Okay, here you see. So if you differentiate d by dx of x square is, that is x to the power of n type it is. So it becomes 2x. This becomes 2x plus differentiation by earlier we used to differentiate this dy by dx, but here we have to differentiate this. So this becomes 2y into dy by dx equals to differentiation of a constant is 0. So this becomes 0. Then here after differentiating he is asked you find dy by dx. So you have to solve for dy by dx. How to go about it? I teach you. So here assume y alpha has to be differentiated and later on you will find dy by dx. This is a proper way. So this becomes what? I revert. Okay. So that is 2y into dy by dx equals to, send this to the right hand terms. Here we have to keep the dy by dx terms on one side, the remaining non dy by dx terms on the other side. So I am trying to retain this dy by dx on the left hand side and trying to send this non dy by dx terms to the right hand side. So what happens here? This becomes minus 2x. Done. So what I do, I have to find out dy by dx. That is dy by dx equals to what? That is 2x by 2y. We have minus value, we have minus value. Here 2 cancels, we are left with x comma y. Add up this. So we are asked to find dy by dx. We have got dy by dx. So therefore dy by dx equals to what? So this 2 cancels, got it, minus x by y. This is our answer. So do you think it's a very simple problem? Yes. We will make all problems look simple provided you and I work along with it. So whatever I teach you, you have to sit at home, try to practice it then and there itself. Otherwise this becomes a burden on you and later on you will feel it difficult, you will find it difficult. So then there itself try to practice it. So we will go for second problem. So dear students, we have one problem. We have to differentiate this. So let's differentiate. What I will do is, this is d by dx of x square. I take this 3 outside, 3 into d by dx of x comma y plus d by dx of y square equals to 0. Now let's differentiate this. So if we differentiate this, what happens? X square we get 2x plus 3, I write as it is. This becomes product rule, x into d by dx of y plus y into d by dx of x plus d by dx of y square equals to 0. So I have already differentiated this. This will be 2x plus this will be 3 into x. D by dx of y is dy by dx plus we have 3 here, 3 into y, this is 3y into d by dx of x is 1, and let me not write that, plus this becomes d by dx of y square. Treat this as x to the power of n, so here y to the power of n, so nx to the power of n minus 1 or n into y to the power of n minus 1. Third, it becomes 2y into differentiation of y dy by dx equals to 0. So what I will do, I will keep the dy by dx terms on the left hand side, the non dy by dx terms on the other side. So what I will do, that is 3x into dy by dx plus 2y into dy by dx equals to, when this goes there it becomes minus 2x and this becomes minus 3y. I rub this first two steps. So I'll take, okay, so dy by dx common, dy by dx I'll take common, so this becomes 3x plus 2y equals to, I'll take minus sign and minus sign common, is what, 2x plus 3y, because we minus multiply this, you get again minus sign here. I rub this. So what I do, what I have to do, I have to find dy by dx. So what happens to dy by dx? This should go to the denominator. Now dy by dx equals to what? This is minus 2x plus 3y divided by, this is 3x plus 2y. Therefore, dy by dx equals to minus 2x plus 3y divided by 3x plus 2y. This is the answer. So dear students, I hope you have understood this. You are asked only to find dy by dx in this sort of implicit functions. Try to find dy by dx. So you have kept the dy by dx terms on the left hand side, the remaining non dy by dx terms on the other side. That sort is implicit function. So let's go for the next problem. Students, we have another problem. Ax square plus 2hxy, ax square plus 2hxy plus y square equals to 0. This equation is nothing but an equation to a straight line. So you are asked to differentiate this equation. So let's do it. That is d by dx of, I'll take this here outside, okay, right, no issues, x square plus d by dx of 2h xy plus d by dx of y square equals to 0. So what I will do, I will take this a square, a outside, this will be d by dx of x square plus, I will take this constant 2h outside, 2h into dy dx of x comma y plus dy dx of y square equals to 0. So let's apply product rule for this. So this is equals to what? A into d by dx of x square plus 2h. This is x into d by dx of y plus y into d by dx of x plus d by dx of y square equals to 0. So now we are able to differentiate this. So this, what happens to this? If we differentiate x square, it becomes 2x. So 2x into a, 2ax, 2ax plus 2h, I'll keep as it is. This is x into d by dx of y is dy by dx, dy by dx plus y into d by dx of x is 1. So let me not write that. So this becomes d by dx of y square is this is similar to y to the power of n, that is n into y to the power n minus 1. So that becomes 2y into dy by dx equals to 0. So one more step, this becomes 2ax multiply, this becomes 2hx, I'll write 2hx into dy by dx plus 2hy plus 2y into dy by dx equals to 0. So what I'll do is, I'll divide throughout by 2. I'll rub this. So dividing throughout by 2, what happens? We are left with what? Ax plus hx dy by dx plus hy dy by hy plus y into dy by dx equals to 0, because you divide 0 by 2, it is 0 only. So I divide throughout by, that is by dividing by 2. I'll rub this. So what I'll do, I'll try to bring dy by dx on one side and other things on the other side. So what I'll do, first I'll take common by rearranging. By rearranging, we get hx into dy by dx plus y into dy by dx equals to, this becomes minus ax and minus hy. I rub this. Now I take common. Dy by dx common. So you have hx plus y equals, I'll take minus common here. This becomes ax plus hy. Or here also I'll use common bracket I'll rub this. So we want dy by dx. So dy by dx will be what? This divided by this. That is, now dy by dx equals to what? Equals to, that is, minus ax plus hy. I bring this down, this becomes hx plus y. Therefore, dy by dx equals to what? Minus ax plus hy divided by hx plus y. This is the answer. So dear students, we have one more problem. X to the power of y plus y to the power of 4 minus a square xy equals to 0. It's a very simple problem. I didn't have to do this, but anyway, I feel there might be some students who have not understood properly. For the benefit of those students, I'll do this problem. So we have asked to differentiate this. So that is d by dx of x to the power of 4 plus d by dx of y to the power of 4. I'll take this a square outside, minus a square into d by dx of x comma y equals to 0. So let's differentiate this. So what happens? This is equals to d by dx of x to the power of 4 plus d by dx of y to the power of 4 minus a square. I'll use a square bracket. This is x into d by dx of y plus y into d by dx of x equals to 0. So what I have done, I have used product rule here. You have to use, not I, you have to use the product rule because there are two functions. So let's differentiate this. So this is our type x to the power of n, that becomes 4 into, that is 4x cube plus 4 y cube and dy by dx. You have to differentiate the y's also. So this minus a square I take as it is, and this becomes x into dy dx of y is dy by dx plus y equals to 0 because d by dx of x is 1. So next step, that is 4x cube plus 4y cube into dy by dx minus a square x into dy by dx again minus a square y equals to 0. I'll rub this. I'll group dy by dx terms on one side and other things to I'll transfer the remaining to the right hand side. So what I'll do, first I'll transfer this this becomes what? 4 y cube into dy by dx minus a square x into dy by dx. If you transfer this, that becomes plus a square y, and this becomes minus 4x cube. So once you transfer this, that becomes minus. So what I will do, I will take common, dy by dx as common, dy by dx common, we left with what? That is 4 y cube minus a cube x equals to a square y minus 4 x cube. So I want dy by dx, then dy by dx equals to, that is a square y minus 4 x cube divided by 4 y cube minus x. Please change this. This is x square, ax square, and this also ax square, and this also becomes cube. So I had written cube, so change that. Yeah, this is a, therefore dy by dx equals to a square y minus 4 x cube divided by 4 y cube minus a square x. This is a required answer. So dear students, we have been given find dy by dx if 2x square minus 3xy plus 4y square equals to 1. So you have to find dy by dx. So as the method I had told you, what is implicit function, you have to use implicit function and equate this to 0, that is f of x comma y, that is nothing but f of x comma y equals to 0. It means to say that you have to differentiate both x as well as y with respect to x and equate it to 0. The moment you differentiate this, on the right hand side take it 0 and try to bring dy by dx separately, as the second condition says, try to bring the dy by dx on one side, the remaining portion on the other side. Let's see, and we'll work out this problem. One problem if I do, you'll understand. So let's start. So dear students, don't write let y equals to so and so, because here this is an implicit function. The question of y doesn't arise here, y equals to so and so. So don't do that mistake, don't commit that mistake. As it is differentiate, you'll get answer. I'll show you how to go about it. So let's differentiate this with respect to x. So what happens here? This will be d by dx of 2x square minus d by dx of, I take this 3 outside. Okay, next line, 3x square plus d by dx of 4y square equals to d by dx of 1. Okay, so what happens here? So if I take this 2 outside, okay, one step for first problem I'll do this. So this will be 2 into d by dx of x square minus 3, I'll take it outside, 3 into d by dx of x square plus 4 outside, I'll take d by dx of y square equals to d by dx of 1. Done. So what happens here? So this becomes equals to what? This is 2 into 2x minus, use product rule here. This will be 3 into, here you have to differentiate both x and y with respect to x. Remember, this is not like previous problems. So in implicit functions you have to differentiate both x as well as y. I'll show you use this. So this will be x into d by dx of y plus y into d by dx of x, close the bracket, plus four into y square. This will be as x to the power of 2. Similarly, you have to write this 2y into dy by dx, this equals to 0. Differential of constant 0. See here, in implicit function, I once again inform you in differentiate and implicit functions, you have to differentiate y also with respect to x. So here this becomes 2y into dy by dx. Remember this. Now what I have to do? We have a dy by dx here, we have a dy by dx here. So we have to try to bring everything on the one side, dy by dx terms on the left hand side and remaining terms on the right hand side as per the method. So I'll rub this. So this becomes what? 4x minus 3, I'll take it outside. This becomes 3 into dy by, if we differentiate y with respect to x, it becomes dy by dx plus y into dx by d by dx of x is 1. So this is 1, close the bracket. So plus 4 into 2, this becomes 8. 8 straight away, right? 4, 2 4s are 8 into y into dy by dx equals to 0. So here once again I repeat this step. So 2 as it is, d by dx of x square is 2x, 3 I have written, use product rule for this, x into d by dx of y plus y into d by dx of x. So product rule. So what happens here? This becomes 3 into dy by dx plus y into d by dx of x is 1 plus this becomes 2y, 4 I have taken 2y into remaining, we have y here, differentiate that also. Done. See, in the case of, you take this y equals x to the power of n, isn't it? What we used to do? Dy by dx equals to what? That is n into x to the power of n minus 1 into this portion, that is d by dx of x, isn't it? Or others I'll do a problem itself here. So we will take 3. This used to 3 into 3 minus 1, 2 into this portion d by dx of x is 1. So 2 into y, this big y will be remaining, so dy by dx. Done. So let's simplify this. So no 3 here, I have already taken 3 here, sorry. X into dy by dx plus, yeah, x as it is. So we have kept differentiate dy by dx, dy by dx plus y2. So this is equals to what? 4x minus 3x dy by dx plus 3y plus 8y dy by dx equals to 0. So what I will try to do, I will try to group this dy by dx in such a way that try to group this dy by dx, that is 8y plus dy by dx minus 3x into dy by dx equals to, we have 4x here plus 4x plus 3y. So I am going wrong today. So this is 8y into 8y dy by dx minus 3x dy by dy. So what I will do here, I will try to separate this. What is common here? Dy by dx. So I rub this. So I will try to take the common. Dy by dx equals to, this will be 8y minus 3x minus 3x, this is equals to 0. I will send this on the right hand side. This becomes what? Minus 4x minus 3y. Well, as per the rule, we have to club dy by dx on the left hand side or on the right hand side, separate them. So I have separated dy by dx on the left hand side and I kept the remaining non dy by dx terms on the other side. So I will rub this. That is dy by dx equals to, I take minus common, this becomes 4x plus 3y. I bring this on the denominator, that is 8y minus 3x. Therefore, dy by dx equals to minus 4x plus 3y by 8y minus 3x. This is the answer. So dear students, we are given a problem. Find dy by dx if 2x square minus 3x5 plus 4y square equals to 1. You are asked to find dy by dx. So I had told you, try to bring the dy by dx terms on one side and the terms which does not contain dy by dx to the other side. So what we will do is, try to differentiate this as it is. Don't try to take y equals to this as in the case of earlier problems. Here straight away differentiate this with respect to x, we get answer. So let's see how to solve this problem. So given 2x square minus 3x5 plus 4y square equals to 1. Differentiating with respect to x, we get we get, that is d by dx of 2x square minus, I'll do like this, I'll take this 2 outside straight away, let's not, this is, I'll take 2 outside, d by dx of x square minus 3 into d by dx of xy plus 4 into d by dx of y square equals to d by dx of 1. So dear student, what I have done, I have to differentiate this with respect to x. So here you and we have to take differentiate x as well as y. That's what is implicit functions. So here what happens here, if you differentiate this, what happens here, this becomes 2 into 2x minus 3, I'll write as that is. I'll take this, you have to use product rule for this, because here don't ignore y, even y has to be differentiated with respect to x. So this will be x into d by dx of y plus y into d by dx of x. So close the bracket plus 4 into, so this will be x to the power of n into x to the power of n minus 1. So this becomes 2y into differentiation of y, that is dy by dx. This differentiation of a constant is 1. Differentiation of a constant 1 equals to 0. So what happens to this? So this is equals to 4x minus 3 as it is. This becomes x into differentiation y is dy by dx. This will be dy by dx plus y into d by dx of x is 1. This will be plus 4 2s are 8 y into dy by dx equals to 0. So I'll rub this. Let's simplify this. This is 4x minus 3x into dy by dx minus 3y. You have this 3 is common to both, so minus 3y plus 8y into dy by dx equals to 0. We will try to group dy by dx, we try to keep dy by dx on one side and the remaining non dy by dx terms on the other side. So as per the definition we will do this. So here what we have, I will take this first, 8y into dy by dx minus 3x into dy by dx plus 4x minus 3y equals to 0. What I have done, I have rearranged it. I have taken, instead of taking this first, I have taken this because I want to avoid this minus sign. So this becomes, so 8y into dy by dx minus 3x into dy by dx plus 4x minus 3y. Done. What I am trying to do? I am trying to keep dy by dx on one side, the remaining on the other side. So what happens here? This is 8y into, I am writing one step extra, dx minus 3x into dy by dx equals to, so we are sending this becomes, so when this goes there, this becomes 3y minus 4x. So I am sending this, so the moment you send this to the right hand side, plus 4x becomes minus 4x, yes, 3y becomes plus 3y. So instead of writing minus to begin with, I have tried to change this. Instead of making 4x minus 4x plus 3y, I have written 3y minus 4x. Both are same, only thing the sign changes. So I'll rub this. So here this contains dy by x, this also contains dy by dx. I'll take dy by dx as common. So take dy by dx as common. So here this becomes 8y minus 3x equals to 3y minus 4x. Now, what is dy by dx? I will keep dy by dx, I send this to the denominator, that is dy by dx equals to what? 3y minus 4x divided by, this goes to the denominator, that is 8y minus 3x. Therefore, dy by dx equals to 3y minus 4x divided by 8y minus 3x. This is the answer. This is the way you should solve implicit functions, problems on implicit functions. So he has asked you to find dy by dx, so therefore dy by dx equals to 3y minus 4x by 8y minus 3x. This is the required answer. So let's go for second problem. Students, we have a problem here. If x into under the root 1 plus y into under the root 1 plus x equals to 0, prove that dy by dx equals to minus 1 by 1 plus x square, the whole square, 1 plus x the whole square. So how to go about it? So we need to have a minus value here. So the best is I have to send this to the right hand side. Let us see this. We'll solve this problem. Solution. I can write this as what? Given problem is x into 1 plus y equals to y into 1 plus x. I can write like this. So once it goes up, it becomes minus sign. Right? So now we have to get this 1 plus x the whole square. What to do? We'll square both the sides. So squaring both the sides, we get what? That is x square into 1 plus y, because root x into root x is x. So root under the root 1 plus y into under the root 1 plus y becomes 1 plus y. This equals to minus becomes plus y square into 1 plus x. So what I do, I try to bring this once again towards the left hand side. So this becomes what? X square 1 plus y minus y square into 1 plus x equals to 0. So we multiply this. So what happens here? This becomes x square plus x square y minus y square minus x y square equals to 0. So I'll rearrange this by rearranging. What happens? That is x square minus y square plus x square y minus x y square equals to 0. So I take one step here, I solve this. This is x square minus y square plus I take xy common, this becomes x minus y equals to 0. But what is x square minus y square and a square minus b square? A square a into a plus b into a minus b. So this becomes, that is x plus y into x minus y plus xy into x minus y equals to 0. So what I do, I take x minus y common. So x minus y common. So we left with what? X plus y plus xy equals to 0. I wrote this. So what I do is I divide throughout by x minus y. Divide throughout by x minus y. What happens? X minus y divided by x minus y get 1. So on the left hand side it becomes x plus y plus x on right hand side 0 by x minus y becomes 0 equals to 0. So I set this x on the left hand side, that is y plus xy equals to minus x, and y is common here, 1 plus x equals to minus x. What happens to y? So y equals minus x by 1 plus x. So this is our equation 1. Make a note. So what I do, I differentiate this with respect to x, equation 1. Differentiate equation 1 with respect to x. We get what? dy by dx equals to, I take this minus sign outside, so this will be d by dx of x by 1 plus x So now I'll use quotient rule because this is a u by v method. So how to go about it? That is dy by dx equals to, I take this minus sign as it is. So this is 1 plus x the whole square. So 1 plus x into d by dx of x minus x into d by dx of 1 plus x. This is our quotient rule. So I do it here. So dy by dx equals to minus sign, I take it outside. So 1 plus x into d by dx of x is 1 minus sign is a minus sign, minus x into d by dx of 1 is 0 and d by dx of x is 1. So we get again 1 divided by 1 plus x the whole square. Done. So this becomes minus outside. We will remove the bracket, 1 plus x minus x by 1 plus x the whole square. So what happens here? Plus x minus x cancels. So I left it minus sign outside. So I left it 1 by 1 plus x the whole square. And what is this on the left hand side? That is nothing but dy by dx. So therefore dy by dx equals to, remove the bracket, this becomes minus 1 by 1 plus x the whole square, which is proved. We got minus 1 by 1 plus x the whole square. Hence we have proved it. So this is how you have to go about. It's a simple problem. It needs experience to solve this problem. So the more the problem you solve, it becomes more easier for you. So what you do is, apart from what I teach, take that as a reference and try to follow the method, procedure, and try to work out more problems so that you will be fully conversant with most of the problems. Otherwise it will be difficult for you to score full on full. So dear students, I am just a guide, a reference, and just use me as a reference to solve this problems. I will show you the method, the procedure, and try to solve more problems, and you achieve more experience and try to solve problems one by one, because you get solution for every problem only by practice. Practice makes perfect. So we'll stop this and take a next problem. So dear students, we have one more problem. If x to the power of m into y to the power of n equals to x plus y to the power of m plus n, prove that x into dy by dx equals to y. So here I have told you earlier, whenever you get anything to the power, take log. Only by taking log only you will be able to solve the problems, otherwise we can't. So what we will do? We will take log. So what happens here? Take log. Taking log on both sides. We get what? M log x plus n log y equals to m plus n log x plus y. So now after taking this, differentiate this equation. So that is, by differentiating, that is d by dx of m log x plus n log y equals to, I take this m plus n constant outside and differentiate this d by dx of log of x plus y, and we get a square bracket. Okay. Now let's differentiate this. So I take this m outside, which is equal, implies m into log x is 1 by x plus n into log y. So it is 1 by y, differentiation of, so log y is 1 by y, differentiation of this is dy by dx into dy by dx equals to this constant m plus n, I write as it is. So this is 1 by x plus y into d by dx of x plus y. I should have avoided this step. Okay, let us straight away solve this. So you know this, you have to take dy by dx. So this becomes what? 1 plus dy by dx. So if you differentiate log x, log of x plus y, that is 1 by x plus y into d by dx of inner function. So this becomes what? D by dx of x is 1 plus dy by dx. So we will rewrite this. So what I do, this can be written as m by x plus n by y into dy by dx equals to m plus n by x plus y into 1 plus dy by dx. I'll rub this to, I'll rub this one step. So now we have to solve for dy by dx. See that dy by dx is on one side and other non dy by dx comes on the other side. How to go about it? First, follow me. What I do is, this is equals to, I multiply this. So I will not put bracket here. If I put bracket, it becomes for everything. So this is n by y dy by dx, m by x plus n by y into dy by dx. So equals to, I multiply this, this becomes m plus n by x plus y plus, I multiply this, m plus n into, you multiply the entire term, it becomes this, and plus m plus n by x plus y into dy by dx. Done. What I have done? I have multiplied this into 1. We got this m plus n by x plus 1 plus m plus n divided by x plus y into dy by dx. So what I do, I try to bring this dy by dx terms over and I try to shift the non dy by dx terms to the other side. So what happens here? So this is n into y dy by
dx. I bring this here, this becomes minus m plus n by x plus y into dy by dx equals to, so we have left here m plus n by x plus y minus m by x, and with this so I take dy by dx common. Dy by dx common, so we left with what? N by y minus m plus n by x plus y equals to m plus n by x plus y minus m by x. Are you following? So what I do, I take LCM on both sides. So what I do first here, that is dy by dx, this will be y into x plus y. This is a LCM divided by, here y goes here one time, this becomes x plus y y goes on into n minus m plus n, it goes one time into y. So here again LCM is x into x plus y. X plus y goes one time, this becomes x into m plus n minus this x goes here, this becomes m into x plus y. What I have done, I have taken LCM, repeat once again. You have y and x plus y as LCM. So here y goes one time and left with what? X plus y. So x plus y into n minus x plus y cancels and left with y. So y into m plus n. On the right hand side we have x into x plus y. So here what happens? X plus y goes, we are left with x into m plus n minus x and x cancels. So we will get m into x plus y. So what we will do? We will multiply this. That is dy by dx equals to, this will be n into x plus ny minus my minus ny by y into x plus y equals to, again here mx plus nx minus mx minus my divided by x into x plus y. So plus mx minus nx cancels, plus ny minus ny cancels, that is dy by dx will be nx minus my. So I'll bring this. Okay, almost settled, right? No problem. Divided by y into x plus y equals to, this is nx minus my by x into x plus y. We have this cancels and this x plus y cancels. So x plus y gets cancelled, x plus y gets cancelled. This gets cancelled, this gets cancelled. We are left with what? dy by dx equals to 1 by y. 1 by y equals 1 by x, right? So by cross multiplying again, this becomes dy by dx into x equals to y. So this is proved. That is x into, by rewriting, x into dy by dx equals to y. Hence proved.
Given, find x if ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So we have to find dy by dx, but this is an equation to a straight line. So let's find dy by dx. So dear students, to find that we have to differentiate both sides with respect to x. So what happens here? That is d by dx of ax square plus 2h xy plus by square plus 2gx plus 2fy plus c equals to 0. Equals to 0. So what happens here? If you differentiate this, this becomes 2ax. I'll take this 2h common. I take this 2h outside, and d by dx of x comma y plus I take by outside, d by dx of y square plus I take 2g outside into d by d of x. I'll take 2f outside, d by dx of y plus this is differentiation of a constant will be 0 straight away. Okay, I'll write one step. So d by dx of c equals to 0 plus d by dx of c equals to 0. So what happens here? So this becomes 2ax plus 2h. This becomes x into dy by, if you differentiate product rule, x keep it as it is, y will be, if you differentiate y, it becomes dy by dx plus I'll keep
y as it is, d by dx of x is 1 plus b into this becomes 2y into dy by dx. This becomes 2y into dy by dx plus 2g dy by dx of x is 1, and this becomes what? Two f into d by dx, 2f d by dx of y is dy by dx, and this becomes constant, that is equals to 0. D by dx of this becomes 0 since it is a constant. So let's simplify this. I rub this. I'll rub this too. Well, I don't want you to get confused. Equals to 0, that I have written there. So what happens here? This equals 2ax plus we multiply this 2h dx dy by dx plus 2h into y, because if you multiply you have this, plus 2b y into dy by dx plus 2g plus 2f dy by dx equals to 0. I'll rub this. So what I'll do it, to simplify this, I'll divide throughout by 2 because all the terms contains 2. So divide everything by 2. So what happens here? This becomes ax plus hx dy by dx plus hy plus dy by dx plus 2g plus, sorry, only g, so g plus f into dy by dx equals to 0. So what I'll do, I'll bring all the dy by dx term on the left hand side, the remaining on the other side. So this becomes what? This becomes hx dy by dx we have here plus by dy by dx we have here plus f into dy by dx. I'll send all this to the left hand side. So this becomes minus ax minus hy minus g. So I'll take dy by dx common, dy by dx common, you have here hx plus by plus f equals to, I'll take minus n common, so this becomes ax plus hy plus g. So dy by dx will be this divided by this. Then dy by dx equals to, we have minus ax plus hy plus g divided by hx plus by plus f. This is the required answer. So dear students, we are given one more problem to differentiate x to the power of 4 plus y to the power of 4 minus a square into xy. So let's differentiate this. That is d by dx of x to the power of 4 plus d by dx of y to the power of 4. I'll take this a square outside, minus a square into d by dx of x comma y equals to 0. So let's differentiate this. So what happens? This is equals to d by dx of x to the power of 4 plus d by dx of y to the power of 4 minus a square. I'll use a square bracket. This is x into d by dx of y plus y into d by dx of x equals to 0. So what I have done, I used product rule here. You have to use, not I, you have to use the product rule because there are two functions. So let's differentiate this. So this is our type x to the power of n, that becomes 4 into, that is 4x cube plus 4 y cube and dy by dx. You have to differentiate the y's also. So this minus a square I'll take as it is, and this becomes x into dy by dx of y is dy by dx plus y equals to 0 because d by dx of x is 1. So next step, that is 4x cube plus 4y cube into dy by dx minus a square x into dy by dx again minus a square y equals to 0. I'll rub this. I'll group dy by dx terms on one side and other things to I'll transfer the remaining to the right hand side. So what I'll do, first I'll transfer this. This becomes what? 4 y cube into dy by dx minus
a square x into dy by dx. If you transfer this, that becomes plus a square y, and this becomes minus 4x cube. So once you transfer this, that becomes minus. So what I will do, I will take common, dy by dx as common, dy by dx common, we left it what? That is 4y cube minus a cube x equals to a square y minus 4x cube. So I want dy by dx, then dy by dx equals to, that is a square y minus 4x cube divided by 4y cube minus x. This is the required answer. In this is x square, ax square, and this also ax square, and this also becomes cube. So I had written cube, so change that. Yeah, this is a, therefore dy by dx equals to a square y minus 4x cube divided by 4y cube minus a square x. This is a required answer. Dear students, we have a problem, x to the power of y into y to the power of x equals to 1. Show that y into y plus x log y divided by x into y log x plus x. So we have to prove this. So whenever we have some problem with powers, try to take log on both sides and solve the problem. I have taught you, I have told you. So let's do this problem so that you will understand. Have patience while doing this problem. So taking log on both sides, taking log on both sides, what happens here? So this becomes y log x plus x log y equals to 0. So log of this becomes 0. So what is this law here? Log M_N equals to log of m plus log n. Log n. So I use that property here. So this becomes y log x plus x log y equals to 0. So now we'll differentiate this. By differentiating with respect to x, we get what? That is d by dx of y log x plus x log y equals to 0. Equals to 0. Now let's differentiate. See, here also you have to use product rule, here also you have to product rule. So this becomes what? Y into, first part I'll take, that is y into d by dx of log x plus, I'll keep log x as it is into d by dx of x. So it is pertaining to this. So I'll use this, a bracket for this. So this plus, I'll take this plus again, I'll use a bracket for this. So this will be again x into d by dx of log y, d by dl of log y plus log y into d by dx of x. Plus log y equals to 0. Let me write one step. I'll rub this. So what I'll do, I'll read it dy by dx on the left hand side and transfer this to the right hand side. So this becomes what? Log x into dy by dx plus x by y into dy by dx equals to, so I'll send it to the right hand side, that becomes minus y by x, and this also I send it, this also becomes log minus log y. So I'll rub this. So I take common dy by dx common, dy by dx common. So we get on the right hand side we have log x plus x by y, and here I'll take minus n as common, I'll take minus n common, this becomes y by x plus log y. So what I'll do, I'll find dy by dx. So what is dy by dx? Dy by dx equals to, first I'll keep the portion above, minus that is y by x plus, okay, I'll write same way, that is y by x plus log y divided by this portion, that becomes what? Log x plus x by y. Now I'll take LCM. This becomes dy by dx equals to a minus sign, I'll use a flower bracket, so this becomes x, I'll take it little down, I'll go to the this one, I'll write it here, minus sign, I'll take this, so x is the LCM here, x goes one time, 1 into y plus x goes, 1 goes x times x into log y divided by, we have here 1. So I'll rub this part is over. So I'll take y as a LCM. One goes y times, so y into log x plus y goes one time, so this becomes x. Right? So what happens here? So the denominator and numerator will come down and this will go to the numerator. So this becomes what? This becomes y into y plus x log y divided by x into y log x plus x. So what we want? We want y into y plus x log y divided by x into y log x plus x. Hence we have proved. So therefore dy by dx equals to y into y plus x log y divided by x into y log x plus x. Hence proved. Hence proved. Whatever they have asked, we have proved it. So dear student, this problem is very tricky. Only thing, you have to be cool and have a lot of patience while solving these problems. Otherwise, you will go wrong. Here, especially when you are taking LCM, you will go wrong, and you have to be very careful with these two steps. If you don't correct it properly, if you don't do it properly, you will go wrong. So be careful while doing this. Practice this problem. So taking log on both sides. Both sides. What happens here? Y log e to base e equals x log y. So we know log x to base e is 1. So this becomes what? Y into 1 equals to x log y. Now let's differentiate this. So this becomes d by dx of y equals to d by dx of x log y. Use product rule here. So this becomes what? That is dy by dx equals to, so this becomes x into d by dx of log y plus log y into d by dx of x. I rub this. That is dy by dx equals to x into d by dx of log x is 1 by y into dy by dx into dy by dx plus log y into so d by dx of x is 1, so into 1. So what happens here? That is dy by dx equals to x by y dy by dx plus log x, sorry, log y. So what I will do is I will transfer this to the left hand side because we have a dy by dx. So this becomes then dy by dx minus x by y dy by dx equals to log y. So I rub this. So I will take dy by dx common, dy by dx common. So this becomes one minus x by y equals log y. I rub this. So I will take LCM here, dy by dx equals to y minus x by y equals to log y. So I cross multiply dy by dx into y minus x equals to y into log y, or dy by dx will be, this will go to the denominator. Then dy by dx equals to y log y by y minus x. I will rub this. Y minus x. So what is y? But y equals what? So from the equation we have calculated, that is y log e equals to x log y, isn't it? So this becomes y equals to x log y, isn't it? So what I will do, so wherever y is there, I will put this x log x, x log y. But y equals x log y from the problem, from the given problem, isn't it? From this we get y equals to x log y, x into log y. So I will replace that. So I call this as equation 1. So I will rub this, please make a note, I will rub this. Now substituting y equals x log y in equation 1, what happens? So this becomes dy by dx equals to y we have, I'll put this in bracket, y is what? X log y, x into log y into log y divided by, what is y? Y is x log y, x log y minus x. So I'll put this within a bracket. I rub this. So solve for this. So log y into log y is log y square. So that becomes dy by dx equals to, we have an x into log y into log y is log y the whole square divided by, I take x common, so x common, this is log y minus 1 because x is common, so this x cancels, so I left it log y the whole square divided by log y minus 1, we got it. That is dy by dx equals to log y the whole square divided by log y minus 1. Hence proved. Dear student, we can expect these sort of problems in examination. Be careful, this is short and sweet. The examiner wants to test your knowledge, so he might give such problems for you for 4 marks. Be careful, try to practice this, so don't be careless. So once again go through the problem and try to analyze the problem and try to learn it. We have done a number of problems in implicit functions, so if you go on doing, there is no end for it. So I can do even another 50 to 100 problems. So this concept is more than enough for you to apply yourself and do it. So if you need, try to take some textbooks, work it on the same principles, same basis, same method, you will get it. The more you practice, the more perfect you will be. So let us consider to be, this should be the last problem from implicit function. So if you want a comment, you make a comment in my this one. If you want more problems, I will do it. Otherwise this is sufficient for you. So next we shall either go for successive differentiation or partial differentiation, whichever you want, you put it in the comment section, whichever you want to learn, whether you want successive differentiation or partial differentiation. But before that, there is one small portion left, that is parametric, that is derivative of parametric functions. So and also log functions or inverse method. So I will try to finish that in a 1 hour 1 class, and later on we will go to successive or partial differentiation. So let's do this problem. So dear students, what I will do is, I will send this x to right hand side, this becomes e to the power of x plus y equals x. So what I will do, I will take log on both sides, whenever you get powers, try to take log. Taking log on both sides, taking log on both sides. What happens here? X plus y log e to base e equals to log x. So we are taking log on both sides. So what happens here? We know that log e to base e equals 1. So this becomes what? X plus y equals to log x to base e, if you want to add that. So now we differentiate this. So what happens here? So d by dx of x plus y equals to d by dx of log x. So what happens here? So d by dx of this becomes what? This is 1 plus dy by dx equals to 1 by x. I love this. So I'll keep this dy by dx on the left hand side. This is 1 by x minus 1. So 1 goes to the right hand side, it becomes minus 1. So I'll rub this also. So I'll take LCM here. That is, x is LCM. So what happens here? 1 minus x. X times, so this is dy by dx. Therefore, dy by dx equals to 1 minus x by x, hence proved. Hence proved. So we have a very simple problem, x to the power of n plus y to the power of n equals a to the power of n. So we have been asked to differentiate it. So let's use the standard rule and try to differentiate this. So what happens here? That is d by dx of x to the power of n plus d by dx of y to the power of n equals d by dx of a to the power of n. So we have to differentiate this. What happens here? Once you differentiate this, what happens? This is n into x to the power of n minus 1 plus d by dx of y to the power of n. Similar to this, this will be n into y to the power of n minus 1 d by dx of y, because we have to differentiate even y also, and d by differentiate of constant is 0, since d by dx of constant equals to 0. So right hand side becomes 0. So what happens here? This becomes n into x to the power of n minus 1 plus n into y to the power of n minus 1 into d by dx of y is dy by dx equals to 0. So I'll keep this dy by dx terms on left hand side, the remaining will send it to the right hand side. So this becomes what? This becomes n into y to the power of n minus 1 into dy by dx equals to, this becomes minus n into x to the power of n minus 1. Done. So I'll keep dy by dx, I'll send the remaining portion to the right hand side. So what happens here? Dy by dx, is it visible? No, it is not visible. So I'll rub this. So what happens here? Dy by dx equals to, on the right hand side we have n into x to the power of n minus 1. I'll send this to the denominator. So this becomes n into y to the power of n minus 1. I rub this. I rub this also. So what happens here? N and n cancels. We are left with what? X to the power of n minus 1 by y to the power of n minus 1. On the left hand side we have dy by dx. So this is nothing but I can write this as x by y to the power of n minus 1. I can write like this. So I have taken x by y, n minus 1 is common, that power n minus 1 is common to both. So I can write like this. Therefore dy by dx equals to x by y to the power of n minus 1. This is the answer. So to begin with, I did simple problems, and while concluding it, I am going to conclude with simple problems, so that I want you to find yourself very relaxed and cool. So let's go for the next problem. So dear students, we'll take next problem, y into e to the power of x to the, that is e to the power of x square plus tan x plus log of sin x. So this is a product rule and this is composite function. So let's solve this. So what we'll do? So d by differentiate this. So he is asked you to differentiate, that becomes y into e to the power of x square plus tan x plus log of sin x equals to 0. So here product rule, this becomes what? This is y into d by dx of e to the power of x square plus e to the power of x square, I will write as it is, and d by dx of y into d by dx of y plus d by dx of tan x plus d by dx of log sin x. So we'll differentiate now. So what happens here? This is y into e to the power of x is e to the power of x itself. So this becomes e to the power of x square into differentiate the inner portion, that is 2x plus e to the power of x square, dy by dx of y is dy by dx plus d by dx of tan x is secant square x, plus this becomes d by dx of log, means first is 1 by sin x, and d by dx of inner function, that is cos x. So what happens here? This can be written as 2xy into e to the power of x square plus e to the power of x square into dy by dx plus secant square x plus cos by sin is cot x, So I'll rub this.
So I'll say this is on the right hand side we have equals to 0. So here also equals to 0. So I'll send this to the right hand side. So this becomes what? This is e to the power of x square into dy by dx equals to, so I send this equals to minus 2 xy into e to the power of x square minus secant square x minus cot x minus cot x. I love this. I'll take minus sign common, so this becomes 2 xy e to the power of x square plus secant square x plus cot x. This is e to the power of x square dy by dx. So I want dy by dx, I'll send this to the denominator. So now dy by dx equals to minus 2xy e to the power of x square plus secant square x plus cot x divided by e to the power of x square. Therefore, okay, you're right. Therefore, dy by dx equals to this. So what I'll do, in order to save time, I'll change this. Therefore, dy by dx equals to this answer. But you are not supposed to do that. In the next time, you write this and repeat this. So we'll go for the next problem. So if you want to rearrange this, we'll do it. So let's rearrange once again. Not necessarily you can leave as it is, but still dy by dx. Therefore, I'll write equals to what? Instead of writing 2xy, I'll start with secant square x plus cot x plus 2 xy e to the power of x square this minus sign is there, minus sign divided by e to the power of x square. This is the final answer. You can write, you can leave it as it is, but if you want to decorate it, you can go ahead. So we'll go for the next problem, dear students. So dear students, this is a very simple problem. We'll do this. So we have e to the power of x minus y. So take log on both sides. So in this case already we have a log. For that reason I have chosen this problem.
how to go about this. So what I will do, I can write this e to the power of x minus y equals to log x minus log y. We know that since log of a by b equals to what? Log a minus log b. I have used this concept here to solve this problem. So when I teach you about logarithm functions when I am doing next class, so for this problem you try to know this much and we shall apply here and do the problem. Now we will differentiate this by differentiating. What happens here? D by dx of e to the power of x minus y equals to d by dx of log x minus d by dx of log y. So what about this? D by dx of e to the power of ax. What is d by dx of e to the power of ax? We know that this becomes e to the power of ax into a, right? We will use that concept here. So this means what? E to the power of x minus y into d by dx of x minus y equals to d by dx of log x minus d by dx of log y. Done. So what happens to this? This becomes e to the power of x minus y. So d by dx of x is, I will use a bracket. So d by dx of x is 1 and d by dx of y is dy by dx. dy by dx. So this becomes what? Log x is 1 by x minus, this becomes d by dx of minus is a minus sign, d by dx of this becomes 1 by y into dy by dx. I love this. Done. So I'll rub this also. So if you multiply this, you get, this is e to the power of x minus y minus e to the power of x minus y into dy by dx equals to 1 by x minus 1 by y into dy by dx. I love this. So I bring this term towards the left hand side. So this becomes 1 by y into dy by dx. This minus becomes plus, minus we have e to the power of x minus y into dy by dx equals to, we have 1 by x minus this e to the power of x minus y. So I'll take dy by dx common. Dy by dx common. So you'll have 1 by y minus e to the power of x minus y by 1 equals to I'll use bracket, so this becomes 1 by x minus e to the power of x minus 1 by 1. So I'll rub this. So we'll take LCM. Why is LCM here? dy by dx. Why is LCM? Goes one time. So this becomes 1 minus y into e to the power of x minus y. Equals to x is LCM here, x goes one time, 1 minus x into e to the power of x minus y. So what I'll do, I'll cross multiply dy by dx equals to, this x will go to the numerator, this becomes x into 1 minus y into e to the power of x minus y equals to, this becomes y into 1 minus x into e to the power of x minus y. So therefore dy by dx will be what? This divided by this. Now dy by dx equals to, right hand side we have what? Y into 1 minus x to the power of x into e to the power of x minus y divided by here. Okay, so divided by x into 1 minus y into e to the power of x minus y. Therefore dy by dx equals to y into 1 minus x into e to the power of x minus y divided by x into 1 minus y into e to the power of x minus y. This is a required answer. So very comparative, very simple problem. Only thing you should know the steps to differentiate this and solve this problem. So I am trying to teach you the steps. Please learn this. Very helpful to you. You can stop at this. This is for 4 marks problem. Yes, friends, what I want to tell you is, I have been making videos for 3 hours, 1 hour and above. The reason is, I want you to sit at the table and try to finish that particular portion. For example, if I am teaching something on composite functions, I want you to be prepared with composite functions. So, if I am preparing you for binomial theorem, I want you to be fully equipped for binomial theorem. That's the reason I am going for 3 hours continuous video. So, along with it, this time I have thought, because somebody suggested me, what I will do is, as usual, I will be posting 3 videos or 2 hours videos, 3 hours video, 2 hours video, or 1 hour, whatever it is possible, depending upon the problems I have. So, in addition, I am trying to make some short videos for 15 minutes, 20 minutes, 30 minutes to make you understand on some important problems for examination purposes. There are some problems which I have not dealt it because that whole problem will take a lot of time. So, what I have done, so henceforth, because I am free a bit now because of college holidays, so what I will do is, I will try to post as much as videos as possible, but 30 minutes, 20 minutes, maximum 15 minutes, whatever it is, at least 2 to 3 problems in one video, and try to work only on examination problems which will be most likely to appear in the examinations. That will really prepare you. So, you will have this as well as this. So, if you have any problem, just give me a feedback. I will try to correct myself. I will stop this concept. I will continue whatever I am doing it, or I will continue to do whatever I have told you right now. So, along with this, I will try to post some small videos, short videos for 10 minutes, 15 minutes, 20 minutes on important problems for examination point of view. So, that's clear, students. So, we will go for the next problem if you have understood this. Y equals sine inverse of x comma y. So, we know that d by dx of sine inverse x, I have told you this, that is 1 by under the root 1 minus x square. But here it is not sine inverse x, it is sine inverse of a product rule, that is sine inverse of x into y. In such cases, what you are supposed to do is, bring the sine inverse x towards the left hand side. Then what happens? This becomes what? Sine y equals to x comma y. So, now you can easily differentiate this. So, by differentiation, what happens here? That is d by dx of sine y, usually I am used to that, sine y equals to d by dx of x comma y. Okay. Now, d by dx of sine y is cos y, this becomes cos y, and differentiation of y is dy by dx. So, dy by dx equals to, use product rule here, I keep as it is, x as it is, differentiation of y, that is, let me avoid one step. So, we will straight away differentiate this. So, this becomes dy by dx of y is d as it is, differentiate this. So, this one dy by dx, I will keep y as it is and differentiate the first term, that is into 1, done. So, what I will do, I will try to bring this dy by dx on the left hand side, that is cos y into dy by dx minus x into dy by dx equals to y. I rub this. So, what I will do, I will take dy by dx common, dy by dx common. So, we will get here cos y minus x equals to y. So, what happens to dy by dx? Therefore, that now dy by dx equals to y by cos y minus x. This is the required answer. So what you will do? Therefore, you have to write this compulsorily. So dy by dx equals to y by cos y minus x. This is the required answer. So you do this, you get 4 marks in the examination only for this one small trick. If you don't know, you will get stuck with this and you will be doing the problem. So I have seen some students, they will use this formula here. Instead of x square, they will put xy and start doing the problem and they go wrong. Xy the square and do it. So don't do that, don't commit that mistake. So use this technique. So dear student, it's a very simple problem. Let's solve this. Here we will use product rule. So here it means d by dx of x square into e to the power of y plus d by dx of log x equals to 0. So here what happens? So I will keep this x square as it is, d by dx of e to the power of y plus e to the power of y as it is, and d by dx of x square plus d by dx of log x equals to 0. So this is what this becomes x square. So d by dx of e to the power of x same. So this becomes e to the power of y into, and this becomes d by dx of dy by dx plus e to the power of y into, this becomes 2x plus this becomes 1 by x equals to d by dx of log x is 1 by x. So I will send both of this towards the right hand side. So this becomes what? X square e to the power of y into dy by dx equals to, I will first write this, minus 1 by x minus e to the power of y into 2x on the left hand side, right hand side. I love this. So I will take LCM here and take minus common, minus and common, that is x square into e to the power of y into dy by dx equals to, minus sign I will take common. So 1 plus e to the power of, I will write like this, 2x into e to the power of y so here 1 by x we have, and here 1 by minus sign, so this means plus, so 2x into e to the power of y divided by 1. So we will take one, we will solve this. So this becomes what? X square e to the power of y into dy by dx equals to, minus sign. So x is LCM. X goes one time, 1 into 1, this becomes 1 plus it goes x times. So this becomes what? X into 2x e to the power of y This is x square e to the power of y into dy by dx equals to minus sign. I'll use this common. So 1 plus x into x, x square, that is 2x square into e to the power of y divided by x. Divided by x. So we have an x square here. So let us enter the denominator. So what happens here? You want dy by dx on the left hand side equals to minus 1 plus 2x square e to the power of y divided by, we have an x here, x, I will send this also into x square and e to the power of y, e to the power of y. So what happens? Now dy by dx equals to minus 1 plus 2x square into e to the power of y divided by x into x, x cube into e to the power of y. Therefore, dy by dx equals to 1 plus 2x square e to the power of y divided by x cube into e to the power of y. I will write little. This is the final answer. So dear students, we are given with, we have a problem, that is x log y plus y log x. We have a problem x into log y plus y into log x equals to 0. We have to differentiate this. So very simple problem. Let's solve it. So this is d by dx of x log y plus d by dx of y log x equals to 0. So use product rule in both the cases. So here this equals to x into d by dx of log y plus log y into d by dx of x. Product rule. First keep as it is, differentiate d by dx of log y plus log y keep as it is, differentiate dx. So this is for the first term. Now for the second term, this is so y into d by dx of log x plus log x into d by dx of y equals to 0 and close the bracket. So this is nothing but x into d by dx of log x is 1 by y into y. You have to differentiate y also, that becomes dy by dx
plus log y d by dx of x is 1 plus y into d by dx of log x is 1 by x plus log x into d by dx of y is dy by dx equals to 0. So this is x by y into dy by dx plus log y plus y by x plus log x into dy by dx equals to 0. So log y plus y by x log x. Okay. Now what I will do, I will try to bring dy by dx on the left hand side and the remaining thing on the right hand side. So I will rub this. So what happens here? This is x by y into dx. I take this plus log x into dy by dx equals to, I will transfer this to the left hand side. So this is equals to minus log x minus y by x. So I have taken this on the right hand side. So this plus becomes minus and this plus becomes minus. I will rub this. So I will take dy by dx common. Dy by dx common. So you left with what? X by y plus log x. I will write by 1 equals to, I will take minus in common. I will do like that, I will interchange this. Instead of this, I will take minus y by x minus log y, because let us have same way. So this becomes minus sign. This is y by x plus log y. See, if you multiply, you get again minus, minus into plus, again you get minus. So we will take LCM. So here this is dy by dx, y is the LCM here, y, this is goes one time, x plus y into log x equals to minus sign. So here x is LCM, this is y plus x into log y. So what we will do? We will cross multiply. I have this. I love this also. We cross multiply. So what happens here? So this x into, that is dy by dx equals to this x into x plus y log x equals to minus sign. So y into this is y plus x log y. And rub this. So therefore now dy by dx equals to what? This divided by this, that is minus, I'll use a floor bracket, this is y into y plus x log y divided by, this is x into x plus y log x. So therefore dy by dx equals to this. So what I'll do is, I'll write here, therefore dy by dx equals to minus y into y plus x log y divided by x into x plus y log x. This is the required answer. Dear students, we have one more problem here. So this is equation to an ellipse. So we shall differentiate this equation and find out what is dy by dx. So here by differentiating, what happens? D by dx of x square by a square plus d by dx of y square by b square equals to d by dx of 1. So straight away we differentiate this. If you differentiate x square, it becomes 2x by x plus this becomes 2y, and differentiation of y is dy by dx, dy by dx equals to 0. If you differentiate a constant, that is d by dx of c, constant equals to 0. So what happens? So I divide throughout by 2, that becomes so dividing throughout by that becomes x by a square plus y by b square into dy by dx equals to 0. So I transfer this x by a square on the right hand side. So this is equals to what? I want to keep this dy by dx, that is dy by dx into y by b square equals to, this goes to the left hand side, so this becomes by a square. So let us cross multiply this. What happens? By cross multiplication, I write here, by cross multiplication we get dy by dx, that is dy by dx equals to minus equals to minus x into b square divided by y into a square. Therefore, dy by dx equals to x b square by y a square to the power minus this value. This is the required answer. So this is d by dx of root x plus d by dx of root y. This equals to d by dx of root a. So what happens to this? This is half root x plus this is half root y into dy by dx into dy by dx. Constant is 0. So this becomes 0 since d by dx of constant equals to 0. So I'll move this towards that side. So what happens to this? Dy by dx into half root y equals to minus half root x. So cross multiply. So dy by this is cross multiply. So into it goes there. So 2 goes into root y by there is minus sign to root x. So this 2 cancels. There that is dy by dx equals to what? Minus root y by root x, or also you can write this as this equals to minus under the root y by x. You can write like this or you can write like this, both are same. Therefore dy by dx equals to this is the answer. Whichever you want, you can write like this or like this, both are same. So we'll go for the next problem. So we'll differentiate this, that is dy by dx of x square plus y square equals to d by dx of log x comma y. So this is a product rule here. So this can be done, that is d by dx of this becomes 2x plus d by dx of y square is 2y into dy by dx equals to, so this becomes 1 by x comma y, and here we have to take product rule, x into d by dx of y plus y into d by dx of x. So
this is 2x plus 2y into dy by dx equals to 1 by x comma y. This is x into, this becomes dy by dx plus this is y into 1. Let's simplify this. I'll rub this. Okay, one more step we can write here. That is 2x plus 2y dy by dx. So I multiply this, so this becomes equals to, first case this x is cancelled, you are left with 1 by y into dy by dx plus y and 1 cancels, you are left with 1 by y, 1 by x, sorry, 1 by x. Add up this. Is it visible? Okay. So I'll bring this towards right. We'll by regrouping, that is 2y into dy by dx. I'll bring it here, minus 1 by y into dy by dx equals to 1 by x minus 2x. So I'll take common here, dy by dx dy by dx common. This is 2y minus 1 by y equals to so this is 1 by x minus 2x. We have to take LCM. That is dy by dx equals to y is the LCM, goes one time, that becomes 2y square, one goes y time y into 2y is 2y square minus 1, y goes one time, so 1 into 1 is, so x is LCM. This is 1 minus 1 goes x times x into this becomes 2x square. So cross multiply. So I cross multiply this. What happens? This and this here, that is dy by dx into x into 2y square minus 1 equals to, this is y into y into 1 minus 2 x square. I'll rub this. That is dy by dx equals to this divided by this. So what happens here? This is y into 1 minus 2 x square divided by x into 2y square minus 1. Therefore, dy by dx equals to y into 1 minus 2x square divided by x into 2y square minus 1. This is the required answer. So dear students, we can stop at this. So we have covered more problems on this implicit functions. So by now you are well versed in differentiation up to where, that is up to sum rule, difference rule, product rule, quotient rule, composite functions and implicit functions and even explicit functions. So with this knowledge you should be able to do any sort of problems given to you in the examination. So only thing is you need practice. Without practice we cannot go ahead, and without knowing the formula you cannot go ahead. So you have to practice and try to memorize all the formulas, otherwise it will be difficult for you to understand the subject. You cannot proceed. If you don't know the formula, there is no use going ahead. You can stop at that, because without formula you can't survive. So dear students, I have done justice to you. So try to take out your textbooks and try to work more problems, so that you will be more comfortable, because whatever I thought, I have given you a guidance how to tackle the problems. I have taught you how to do it. So with this concept you should be able to do more problems from textbooks. At least you have to refer 3-4 textbooks, try to get variety of problems and try to work on the same grounds. So all the problems are alike, only thing the values might change and some tricks will be there, you have to use it. So sit across the table and try to practice. If you practice, you will be comfortable with this. So let us stop here and concluding part. Dear students, we will stop at this. We have done enough of problems. So we have done a lot of problems on sum rule, difference rule, quotient rule, product rule, composite functions, implicit functions. So by now you should be in a position to work independently and try to solve any complicated problems given to you, either in the classroom or in the examination. So I request you to refer some books, few books, and try to get variety of problems and try to solve the problems on the same basis, because all problems should be within this group itself, because they cannot be anything apart from this, because I have taught you many complicated problems. So whatever problems, either bring it as standard form or try to apply the tricks whatever I have taught to you and try to solve the problems and try to finish the problems without any mistakes, because that is very important for you. So if you keep your mind off and try to do something, you can't. You have to work your problems with lot of care, with lot of concentration and with patience, otherwise you can't. Mathematics is one which demands, which commands your patience, your interest, your dedication, else we can't. It's just like electricity. If you mishandle it, it will give a shock. So maths is similar to that. If you don't work properly, you will get big zero. So let me, dear students, I'll stop here. If required, I'll do part 2. Otherwise, I'll go to the next chapter, whatever is convenient to you. So I'll end here, dear students, with the hope that you would like and share and subscribe to my channel. So I'm getting very good response from you all. So dear students, keep it up, keep your morale up and try to work hard. I want you to show that your worth in the classroom, that you have come under a good lecture and somebody has been teaching you well. Try to spread the knowledge to others, let them also come up in maths, because I want each students throughout the world to be good in mathematics, and they all should do well in mathematics, because maths is one subject that makes you very intelligent, knowledgeable and sharp. So it will inspire you to counter other chapters, other subjects if you are good in mathematics, otherwise you will be dull. You just refer some students who are good in maths, automatically they will be good in other subjects too. So try to pay a lot of attention on mathematics and be good in maths. So it will develop you overall, and you will be fully equipped to counter any situation given to you. So let me end here, dear students. God bless you, take care and have a nice day. So good night, dear students, and before I conclude, like, share and subscribe to my channel. Thank you, dear students. God bless you.